live. Another very, very important session, that is trailing zeros. Very interesting topic, and this trailing zeros topic is an extension of highest powers topic. Students who are very, very comfortable in highest powers should be able to understand these trailing zeros very, very clearly. In case if you are a student who is watching these trailing zeros session, to all the enrolled students, there are two sessions I did, session number 1 and session number 2, which talks about all the fundamentals of highest powers. Related to highest powers, if you know all the fundamentals, trailing zeros, it will be very clear. Trailing zeros, what is the meaning of trailing zeros? It means zeros at the end. Zeros at the end. Number of zeros at the end. Please write down, sir. Number of zeros at the end. It is called trailing zeros. Number of zeros at the end, it is called trailing zeros. Trailing zeros, we will solve a lot of very good problems from trailing zeros. Like you know, in every classroom, we are going to discuss this structure in every class. Every subtopic goes through this structure. Trailing zeros, first we will do definition based problems, basic foundation level problems, intermediate level problems, advanced level problems, and exam model questions. Exam model questions, totally around 65 plus high quality questions covering all the varieties. I kept it out in these PDF. High quality problems. Students who are preparing at a basic level, definition problems are there. Students who want a very classic level questions, I kept it in the advanced level. Definition, basic foundation level, intermediate level problems, advanced level problems, and exam model questions. Total 65 plus high quality problems are there. I think around 3 to 4 hours are required to complete all the problems. On an average, about 15 to 20 questions we solve it per hour. So I think in case if I develop new questions in the class, it should take anywhere from minimum 3 hours to language. Important key points. Important key points revisited so that we will start using in the foundation problems. What are the important key points? Every natural number can be written as power of prime basis. Every natural number can be written off as a power of prime basis. A natural number based on the number of factors. There are 3 kinds of numbers. One is a prime number, one is a composite number, and another one is neither prime nor composite. Every natural number can be written as a power of a prime basis. Second point, suppose if I take 4 factorial. 4 factorial, the definition of factorial is, it is the product of all natural numbers from 1 to 4. From 1 to 4, what are all the prime numbers? Prime numbers are 2 and 3. So 2 power something will be there, 3 power something will be there. Finding out the value of x and y. Finding out the value of x and y is all about doing the highest powers chapter. Finding out what is the highest power of a prime number. Finding out what is the highest power of a prime number. That is what we discussed in highest power session number 1 and 2. 4 factorial, it is 4 into 3 into 2 into 1, which is 2 cube into 3 into 1. 24 can be written as 2 cube into 3 power 1. Why we got 2 cube? Now if you see, there are 2 multiples of 2. 2 1s are 2 and 2 2s are 4. And 2 2s are 4. 4 I am dividing it by 2. 2 2s are 4. That means there are 2 multiples of 2. But in 4 there is an extra 2. Every power of 4 is also a power of 2. Every power of 16 is also a power of 2. Again divide. 2 1s are 2. 2 1s are 2. So what is 2 plus 1? 3. What is these 2? 2 says that there are 2 multiples of 2. It is 1 multiple of 4. Please write down in the same order, sir. It is 1 multiple of 4. There are 2 multiples of 2. There are two multiples of 2. There are two multiples of 2 and there is one multiple of 4. I hope it is clear. Please make a note in your notebook. Every factorial will have all the prime numbers from n to n if n factorial is given in the question. Another example. If it is 10 factorial, what are all the prime numbers from 1 to 10? Prime numbers from 1 to 10 will be 2, 3, 5 and 7. 2, 3, 5 and 7. So it is x1, these x2, these x3 and it is x4. What are all the prime numbers from 1 to 10? 2 power something, 3 power something, 5 power something and 7 power something. Finding out x1, x2, x3 and x4. Finding out x1, x2 and x3 and x4. It is all about the highest powers. Now see here. 10 I am dividing. Introduction. 2 5s are 10. What does this 5 denote? There are 5 multiples of 2. Again I am dividing. 2 2s are 4. There are 2 multiples of 4. 2 1s are 2. 2 1s are 2. So 5 plus 2 plus 1, it is 8. X1 value, it is 8. What is the highest power of 2 in 10 factorial? It is 8. 10 I am dividing it by 3. 3 3s are 9. What does the 3 denotes? There are 3 multiples of 3. Again divide. There is 1 multiple of 9. So 3 plus 1, it is 4. x2 equivalent to 4. Divide 10 by 5. 5 2s are 10. There are 2 multiples of 5. Definitely there are 2 multiples of 5. 5 1s are 5. 5 2s are 10. So 10, it is 7 1s are 7. So x3 value, it is 2. And x4 value, it is 1. x1. I hope the idea it is clear. First, whenever the factorial is given, a factorial, it will represent a natural number. Every natural number can be written as a power of prime basis. Every composite number, try to translate into power of prime basis. Third, suppose the question can be asked like this. Find the factors for 10 factorial. How many factors are there for 10 factorial? How many factors are there for 10 factorial? 10 factorial. What are all the prime numbers from 1 to 10? 2 power, how much we got? 8. 3 power we got 4. 5 we got 2. 7 we got 1. How many factors are there for this number? How many factors are there for this number? 0 to 8, 9. 0 to 4, 5. 0 to 2, 3. 0 to 1, 2. 15 2s are 30. 39s are 270. If a factorial it is given, first write the number as a power of prime basis. If a factorial is given, write the number as a power of prime basis. Then apply the factors concept. 0 to 8, 9. 0 to 4, 5. 0 to 2, 3. 0 to 1, 2. 9 5s are 45. 45 6 are 270. Some key points revisited. Almost all the questions, whatever we are going to solve based on factorials. So I'm just giving an introduction to factorials. I hope this key point, it is clear. Suppose if the question is, fourth key point, how to find out the factors, it is clear. Find the highest power for. Find the highest power for. First question, 2 in 100 factorial. 2 in 100 factorial. Second question, 5 in 100 factorial. 5 in 100 factorial. Third question, 10 in 100 factorial. Fourth question, 100 in 100 factorial. 100 in 100 factorial. Fifth question, 30 in 100 factorial. 30 in 100 factorial. Next one, 98 in 100 factorial. A recap of all the fundamentals we will do. Find the highest powers for 2 in 100 factorial, 5 in 100 factorial, 10 in 100 factorial, 100 in 100 factorial. Now listen carefully here. The last key point, fifth question, 100 factorial ends with 100 factorial ends with dash number of zeros. Once you understand the Foundation level question, trailing zeros, any number of questions you can solve it. Find the highest powers for 2 in 100 factorial. One by one we will solve. First question, see here, find the highest power for 2 in 100 factorial. 100 factorial is product of all natural numbers from 1 to 100. There is 2 power, 3 power, 5 power, 7 power, and so on up to 97 power. So 100 factorial can be written as a power of prime basis. These 2 power x into k. What is k? K is the power of prime basis. K is the power of prime basis. K is the power of prime basis. 3 power, 5 power, 7 power, 11 power, 13 power, 17 power, and so on up to 97 power. It is always good to write like this because there are certain problems which can be solved very neatly by writing rightly like this. 100 factorial. So 2 power we want. Answer will be 100. 2 5s are 2 50s are 100. Again, what is 50? There are 50 multiples of 2. There are 25 multiples of 4. Every power of 4 is also a power of 2. 2 12s are 24. 2 6s are, 2 3s are, 2 1s are. So add all this because every power of 4 is also a power of 2. 6 plus 3, 9, 10, 22, 90, 47, 97. So 100 factorial can be written as 2 power 97 into k. Highest power of 2 in 100 factorial. Answer will be 97. Answer for this question will be 97. First question, very, very easy question. Second one, 2 is a prime number, 5 is also a prime number. 5 in 100 factorial. 100 factorial can be written as 5 power x2 into k2. Here x1 into k1. So 5 is a prime number. First, how many multiples of 5 are there till 100? 20s are. 5 4s are 20. 20 plus 4 is 24. So it is 5 power 24 into k2. What is the highest power of 5 in 100 factorial? Answer for this question is 24. First and second, easy questions. Given number, it is a prime number. 5 is also a prime number. 10, 100, 30 and 98, they are not prime numbers. A and B are 2, 5 are prime numbers. Just to learn in the same structure, sir. Once we discuss advanced level questions, you will understand why we are going from basics. And the given numbers are composite numbers. Given numbers are composite numbers. Now third question. What is the third question? 10 in 100 factorial. 10 in 100 factorial. What is the concept we discussed? Every natural number can be written as a power of prime basis. 10 is a natural number, so it can be written as a power of prime basis. So if composite number is there, write down it as a power of prime basis. Why we are writing it as a power of prime basis? Prime is the first number. Composite number is the inherited number. Composite number is the children of prime numbers. 4 is derived from 2. 9 is derived from 3. 12 is derived from 2 and 3. 2 and 3 are at the top of the tree. Remaining all are derived. 2 into 5. So already we did it for 2 and 5. 2, what is the answer we got? 100 factorial it is. 2 we got 97. 5 we got 24. 5 power 24 into k. We want 10. 10 is single power of 2 and single power of 5. So I can take 24 into 2 power 73 into k. 2 into 4, 5, it is 10. 10 power 1 will have 1 0 at the end. 10 power 2, 100, there will be 2 zeros at the end. So, what is the highest power of 10 in 100 factorial? 24. Another very, very important point. Number of zeros at the end. number of zeros at the end. Number of zeros at the end. It is also called trailing zeros. Number of zeros at the end. It is also called as the trailing zeros. It is given by highest power of 10. Highest power of 10. Highest power of 10. If I want the number of zeros at the end, I need to take the highest power of 10. 10 is a composite number. A composite number will be written as a power of prime basis. So 2 and 5. Very, very important. Write down in the same structure. At the end of the class, everything will be in a neatly packed, structured order. Number of zeros at the end, it is highest power of 10. 10 power 24 we got. 10 power 24 we got. So number of zeros or number of zeros at the end. From now onwards, I will use the word trailing zeros. Number of trailing zeros for 100 factorial. Number of trailing zeros for 100 factorial will be 24. Number of trailing zeros for 100 factorial will be 24. Now one important key point. Listen carefully, sir. 100 factorial. It is written as 1 into 2 into 3 into 4 into 5 and so on up to 98 into 99 into 100. The definition of factorial is, it is product of all natural numbers from 1 to 100. Now if you see, every second term, it is a multiple of 2. Every second term, it is a multiple of 2. Now, if you observe, every fifth term, if I take 10, every fifth term, it is a multiple of 5. If I am writing 100 factorial as 1 into 2 into 3 till 100, there are 100 terms are there. 50 terms are multiples of 2, but 20 terms are multiples of 5. So obviously the powers of 5 will be less compared to the powers of 2. That means, please write down this point. In factorial problems, power of 5 is less than power of 2. Very, very important key point. In factorial problems, power of 5 is less than power of 2. Because power of 5 is less than power of 2, I will be taking the highest power of 5 if I am finding the trailing zeros for factorial problems. Only for factorial based problems. Number of zeros at the end, we will take highest power of 5. Why we are taking only highest power of 5? 100 factorial is 1 into 2 into 3 till 100. Every second term it is a power of 2, but every fifth term is a power of 5. So number of terms 5 will be present is 20 here, but here it is 50. So the number of terms for 2 are greater than the number of terms for 5. Obviously the power of 5 will be less. In factorial problems, power of 5 is less than power of 2. Power of 5, it is less than power of 2. I hope the idea it is clear. Next question. Next one. 100 in 100 factorial. 100 in 100 factorial. First of all, check whether the given number, it is a composite number or not. 100 is a composite number. It can be written as 2 square into 5 square. So 100 factorial. Power of 2 is 97. Power of 5, we got it as 24 into k. I hope it is clear. What is k? K is the power of prime basis other than 2 and 5. I want 2 square into 5 square. So 2 square into 5 square. Power 12, 2 power 24. It is 2 power 73 into k. So 4 into 25. What is the highest power of 100 in 100 factorial? It is 12. 100 in 100 factorial, it is 12. Some students in hurry, 100 factorial, it is 100 into 99 into 98 into and so on up to 25 and so on up to 5 into 3 into 2, and so on up to 1. Now what probably in hurry, 100 is present only once, they might tick mark 1. But if you see here, 50 into 2 is 1, 25 into 4 is 100. Like that, there are lot of possibilities that will arise. So these, in between 90, there is 5 into 18. 80, there is 5 into 16. 70, it is 5 into 14. Here, 5 into 5, 25, 25 into 16 is a multiple of 200. There are so many powers of 100 that we are getting in 100 factorial. 100 factorial, it is a composite number. Write down it as a power of prime basis. 2 square into 5 square. So 2 square into 5 square, power 12. So 2 12s are 24. 2 12s are 24. Now if you see here, if I take the highest power of 5, it is 24. To get 100, I require 5 square, so 24 divided by 2, it is 12. I hope it is clear. Very, very good question, sir. What are the other questions that we missed it out? 1300 factorial, 98 in 100 factorial. 1300 factorial. First we will understand 1300 factorial. 1300 factorial, what is the next question? F. F will be, F, the question will be 98 in 100 factorial. 98 in 100 factorial. Listen carefully, sir. 98 in 100 factorial. So 98 is a composite number. It can be written as a power of prime basis. 2 into 7 square. 2 into 7 square. 7 square, it is 49. 49 2s are 98. So 100 factorial, it will be 2 power 97. Already we did. For what are the multiples of 7 that I will get? 14 multiples of 7. How many multiples of 49 will be there? 2. 14 plus 2, 16. So 7 power 16 into k. So this will be 2 into 7 square. Power 8 into 2 power 87 into k. So what is the highest power of 98 in 100 factorial? Answer will be 8. Very, very easy question. Then I will get into, like I told you, it goes through the 5 layers. First definition based question, foundation based question, intermediate level questions, advanced level questions, finally exam model. So that everything will be there properly in your notebook. 1300 factorial. 30 is a combination of 3 prime bases. 2 into 3 into 5. 100 factorial. Highest power of 2 in 100 factorial. 97. 5 I got it as 24. 5. So 3 it is. 33s are, 3 11s are, 3 3s are, 3 1s are. 44 plus 3, 47, 48. So it is 3 power 48 into k. So this can be written as 2 into 3 into 5. What is the lowest I can take? 24. 2 power 24 is a sub-element of 2 power 97. 3 power 24 is a sub-element of 3 power 48. So remaining k2 I will get. So what is this answer? Answer will be 2 into 3 into 5. 30 power 24, it will be 24. This is the foundation based problems for the highest powers. To get the number of zeros at the end, to get the number of zeros at the end, we require the highest power of 10. To get the highest power of 10, we need the highest power of 2 and 5. That is the reason introductory questions I discussed. Introductory question, how to find the highest powers. Now let us write down some important questions. Find the number of zeros at the end. Find the number of zeros at the end. Find the number of zeros at the end. For first question. First question. 2 plus 4 plus 6 plus 8 and so on up to 100. First question. 2 plus 4 plus 6 plus 8 and so on up to 100. Second question. 2 into 4 into 6 into 8 into 10 and so on up to 100. and so on up to 100. Next one, 1 into, 3 into, 5 into, 7 into, 9 into, 11, and so on up to 99. And so on up to 99. Next question, 8 into, 16 into, 24 into, 32, and so on up to 800. Find the number of zeros at the end. Zeros at the end, it is trailing zeros. Next question. Next question. If you see here, 2 into, 5 into, 8 into, 11 into, 14 into, 17 into, 20. E. Next, F question. 100 factorial plus 200 factorial. G. 200 factorial minus 100 factorial. H. 200 factorial by 100 factorial. I. 200 factorial into 100 factorial. Into 100 factorial. GHI. J. 91 into, 92 into, and so on up to 100. Various models we will discuss. Find the number of zeros at the end. First question is all even numbers till 100 added. Second question is all even numbers till 100 multiplied. Third question is all odd numbers till 99 multiplied. D is all the multiples of 8 till 800 multiplied. Now this is an AP series 2 into 5 into 8 into 11 into 14 into 17 into 20. Factorials are added. Factorials are subtracted. Factorials are divided. Factorials are multiplied. Factorials, it is not given. It is not given. One by one we will solve the questions. I hope it is clear. First question. Find the number of zeros at the end for 2 plus 4 plus 6 plus 8 and so on up to 100 solutions. I will use a different color. 2 plus 4 plus 6 plus 8 and so on up to 100. So if I take 2 common, now these are all, Sn is nothing but n by 2 into first term plus last term. Sum of n terms in AP it is given by n by 2 into first term plus last term. Why it is n by 2 into first term plus last term? Sn by n. Sn by n is called average. Average in AP it is also called arithmetic mean. Arithmetic mean is given by first term plus last term by 2. Arithmetic mean in AP. What is an AP series? If the series has a common difference same, then it is an AP series. Sum of n terms in AP is n by 2 into first term plus last term. If you don't know, you can derive it by the definition. So, if I use this concept, Sn is n by 2. 2 ones are 2. 2 twos are 4. 2 50s are 100. Total 50 numbers are there. 50 by 2 into first term plus last term. Into first term plus last term. So it is 25 into 102. 25 into 102. Just for your understanding, I am writing it as 100 plus 2. 2500 plus 50. So answer is 2550. How many zeros are there at the end? Only 1 zero it is there at the end. So answer for the first question will be 1 0 is there at the end. Very, very simple. If the series is in arithmetic progression, sum of the terms is given by n by 2 into first term plus last term. 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 50s are 100. N represents the number of terms. So n is 50. First term is 2, last term it is 100. 25 into 102. 102 can be written as 100 plus 2. 2500 plus 50. 2550. How many zeros are there at the end? 1 0 is there at the end. First question, it is over. Second one. What is the difference between the first question and the second question? Second question, the numbers are multiplied. First question, the numbers are added. 2, 4, 6 and so on up to 100. Second question, 2 into B 2 into 4 into 6 into 8 and so on up to 100. 2 into 4 into 6 into 8 and so on up to 100. 2 can be written as 2 ones are, 4 can be written as 2 twos are, 6 can be written as 2 threes are, 8 can be written as 2 fours are, 100 can be written as 2 fifties are. 2, 2, 2, 2. 2 is multiplied twice, thrice, 4 times, 50 times. So it is 2 power 50 into, remaining it will be 1 into 2 into 3 and so on up to 50. 1 into 2 into 3 till 50. It is called 50 factorial. So 2 power 50 into 50 factorial. 2 power 50 into 50 factorial. Factorial is the collection of all the natural numbers from 1 to 50 multiplied in a sequential order. So power of 5s will be less. So it will be 2 power 50 into 50. How many are there? 2 25s are, 2 12s are, 2 6s are, 2 3s are, and 2 1s are. So 10, 20, 2 90s, 47 into 5 will be 5 10s are, 5 2s are. How many powers of 5 are there? 5 power 12 into k. So this will be 2 power 97 into 5 power 12 into k2. To get the number of trailing zeros, I need the highest power of 5. 2 into 5 power 12 into 2 power 85 into k2. So 10 power 12, it will have 12 zeros at the end. It will have 12 zeros at the end. Whenever you are doing the number of zeros at the end, you need the power of 2 as well as the power of 5. You need the power of 2 as well as the power of 5. I hope the idea it is clear. It is 2 power 50 into 50 factorial. 50 factorial highest power of 5 is 5 power 12, 2 power 97. So 2 into 5 power 12 into 2 power 85. 10 power 1 will have 1 0. 10 power 2 will have 2 zeros. 10 power 12 will have 2 zeros. One important note, each and every question, I will write some important notes. Note, find the number of trailing zeros. Find the number of trailing zeros. Number of trailing zeros in 2 power 37, 5 power 63, 2 power 37 into 5 power 17. Find the number of trailing zeros in 2 power 37, 5 power 63 and 2 power 37 into 5 power 17. Number of trailing zeros. Number of trailing zeros. It is a number of zeros at the end. Number of zeros at the end is the highest power of 10. 10 means I need a combination of 2 and 5. 10 means I need a combination of 2 and 5. So, number of trailing zeros, only power of 2. It will not give a multiple of 10. Only power of 5. It will not give a multiple of 10. Here, I need a combination of 2 and 5. 2 into 5 power 17 into 2 power 20. 10 power 1 will have 1 0. 10 power 2 will have 2 zeros. 10 power 17 will have 17 zeros at the end. 10 power 17 will have 17 zeros at the end. These are very, very important basic fundamentals. To get the number of zeros at the end, you need a combination of 2 and 5. Why? Because the number of zeros at the end will represent the highest power of 10. Will represent the highest power of 10. Question number 1 over, question number 2 over. Now see here. Listen carefully, sir. Listen carefully. Based upon this concept, the third question. 1 into 3 into 5 into 7 into 9 into 11. These are all odd numbers. To get the power of 10, we require at least a single power of 2 and a single power of 5. Single power of 2 does not come in this series. So the number of zeros in this third one answer is 0. Why? Because 10 is a combination of 2 and 5. Combination of 2 does not come in an odd number set. Combination of 2 does not come in an odd number set. D, what is the question? 8 into 6 into. Already we did this model. So let us do. Without getting fundamentals right, we will never get into problems. 8 into 16 into 24 into 32 and so on up to 800. 8 into 16 into 24 and so on up to 800. This can be written as, please do not write it as 8 into 100 factorial in hurry. It is multiplication. It is multiplication. This is a mistake. 8 into 1, 8 into 2, 8 into 3, 8 into 4. So this can be written as 8 into 1, 8 into 2, 24 is 8 into 3 and so on up to 8 into 100. 8 is multiplied 100 times. 8 power 100 into 1 into 2 into 3 till 100. 100 factorial. 8 power 100 into 100 factorial. Already we have done good number of problems related to 100 factorial. It is 2 power 300. Why? Because 8 is 2 power 3. 100 factorial. Highest power of 2 is 97. Highest power of 5 is 24. Already we did. So we require 2 power 397 into 5 power 24 into k. So 2 into 5 power 24 into 2 power 373 into k. 10 power 1 will have 1 0 at the end. 10 power 24 will have 24 zeros at the end. Find the number of trailing zeros for this question. Answer is 24. Answer for this question is 24. I hope the idea it is clear. 8 into 1, 8 into 2. In hurry, during the exam time, in hurry, because of not having a non-pressure, because when you are writing an exam time is a pressure situation. It is like a batsman giving an easy catch to the slip. Easily in hurry, you will do this one, because in the process of getting more questions right, you end up solving the easy questions wrong. That is where you will slip down your percentile by at least 5 to 8 percentile. Most of the students who got around 90 to 95 percentiles in the CAT examination has actually got the potential to get 98 plus percentile. You spoiled it because of getting some incorrect answers. Why you got incorrect? It is just because of being impatient. Now, what is the another question? Another question. The series is in AP. 2 into 5 into and so on up to 20. Now, traditional method I will tell you, then optimal method when I am discussing I will. 2 into 5 into 8 into 11 into 14 into 17 into 20. Traditional method. Traditional method. Now listen carefully, sir. Traditional method. I want the number of trailing zeros. Some of the questions you will not find it in the regular textbook. Listen carefully. So only we require the number of trailing zeros. We require the number of trailing zeros. Trailing zeros is highest power of 2 and 5. Highest power of 2 and 5. We require highest power of 2 and highest power of 5. So these I require, these I require, these I require. 11 is not. So 14 I require, 17 I don't require. So the question, few terms are neglected. 2 into 5 into 8 into 14 into 20. Now if you see here, 20 it is 5 into 4. 5 into 5, 5 square. 5 square will definitely come if you multiply in this, because 8 itself is 4 into 2. So what is the number of trailing zeros for this number? Number of trailing zeros for this number will be 2, because we require a power of 2 and 5. If you see here, 2 can be written as 2 into 1. 5 can be written as 5 into 1. 8 can be written as 2 cube. 14 can be written as 2 into 7. 20 can be written as 2 square into 5. How many 2's we got? 2 cube, 2 power 6, 2 power 7. 2 power 7 into 5 into 1, 5 square we got. So this can be written as 2 into 5 whole square into 2 power 5 into some other prime basis. How many zeros are there at this end? It is 2. It's a very easy question. I did it orally. I did this question orally, but if the question is the numbers are increasing, how to solve? Let us first understand this question, then develop the question. How to find the number of trailing zeros if the series is in AP and the number of numerical terms are getting multiplied. Number of numerical terms are getting multiplied. This is the traditional method. Traditional method is nothing but a counting method. I am just counting here. This is not the optimal method. This is not the optimal method. Let us find out an optimal method for a simple problem and let us increase the level of difficulty of this question. Traditional method, I hope it is clear. Now, optimal method. Now listen carefully. Question is 2 into 5 into 8 into 11 into 14 into 17 into 20. How, if this question is given to me, how I'll solve this question? A and C method, which is very logical. Whenever I write Anil Nair's method, I am referring to the logical approach to solve the question. Logical approach, or a student must know this approach. 2 into 5 into 8 into 11 into 14 into 17 into 20. Step number 1. If you observe, the series is in AP. First term it is 2. Difference it is 3. All the terms difference it is 3. So Tn equivalent to A plus n minus 1 into D. If the series is in arithmetic progression, nth term is given by A plus n minus 1 into D. So it is 2 plus n minus 1 into 3. So these 3n minus 1. 3n minus 1. I found out the nth term, which is 3n minus 1. A corresponds to the first term, D corresponds to the difference between two consecutive. 2 plus n minus 1 into 3. Now, if you observe here, n value, if I substitute 1, 3 minus 1, 2. N value 2, 6 minus 1, 5. N value 3, 9 minus 1, 8. N value can range from 1 to 7. Am I right? If I keep n value 7, 3 7s are 21 minus 1. 21 minus 1, it is 20. 21 minus 1, it is 20. Are you all with me? Right? So 1 less than or equivalent to n less than or equivalent to 7. Step number 2. Step number 2. Here 2 is there. Here 2 multiple it is there. Here 2 multiple it is there. Here 2 multiple it is there. Totally on 4 terms, 2 multiples it is there. But on 5, here 1 multiple of 5 is there. Here 1 multiple of 5 is there. That means easily power of 5 is less than power of 2. Power of 5 is less than power of 2. Are you all with me? Power of 5 will be less than power of 2. So I require a multiple of 5. So 3n minus 1. I can get the answer from the multiple of 5 only. So it is 5a. 3n minus 1 is equivalent to 5a. Why? Because from 5 multiples only I will get the answer. I hope it is clear. If you see 1, 2, 3, 4, there are 4 terms which belong to the multiples of 2. There are 2 terms which belongs to the multiples of 5. Because there are less number of terms which belong to the multiples of 5. Only by taking we will get the answer. Multiples of 5 is 5a. So 3n equivalent to 5a plus 1. So 3n equivalent to 3a plus 2a plus 1. Is it clear? This is a multiple of 3. This is a multiple of 3. 2a plus 1 should be a multiple of 3. A minimum value, it is 1. A minimum value, it is 1. What will be the lowest term? It is 5. 5 plus LCM of 3 comma 5 into k. Because it is divisible by 3, it is divisible by 5. So the form of the number is 5 plus 15k. K value 0, 5. K value 1, 20. K value 2, I will get 35. 35 is exceeding 20. So how many we got? Here 1 multiple, here 1 multiple. 1 plus 1, answer is 2. Especially if the series is extremely large, you can use this beautiful approach. Again, I am saying you, 2, 5, 8, 11, 14, 17, 20. The series is in arithmetic progression. Difference 3. So nth term I found out. Nth term is 3n minus 1. N less than or equivalent to, n less than or equivalent to 7. Multiples of 5 are less than multiples of 2. So 3n minus 1, it is 5a. 3n equivalent to 5a plus 1, 3n equivalent to 3a plus 2a plus 1. Multiple of 3, multiple of 3. 2a plus 1 should be a multiple of 3. A minimum, it is 1. So 5 ones are 5. And after this number is divisible by 3, divisible by 5. So the number should be divisible by 3 and 5. 5 plus 15k. K0, I got 5. K1, 20. 20, there is a 1 power of 5. 5, there is 1 power of 5. So 1 plus 1, answer will be 2. Especially, this is an extremely important approach. If you are solving questions like this, 1 into 4, 5 into 4 into 7 into 10, and so on up to 31. And so on up to 31. And so on up to 31. Now see here. We will use it. We will not use any counting process. Step number 1. These terms are in AP. Tn equivalent to a plus n minus 1 into d. Are you all with me? So Tn equivalent to a plus n minus 1 into difference, it is 3. So 1 plus n minus 1 into 3. This is 3n minus 2. 3n minus 2. N can start from 1. N can it take 10? 30 minus 2, 28. 3 11s are 33 minus 2, 31. 1 less than or equivalent to, n less than or equivalent to 11. I hope it is clear. Step number 2. Step number 2. If you observe closely, here multiples of 2, here multiples of 2. So powers of 5. Powers of 5 is less than powers of 2. So I will always concentrate on the multiples of 5. Multiples of 5. Step number 3. Listen carefully, sir. Step number 3. 3n minus 2. Either it can be a multiple of 5. Step number 4. It can also be a multiple of 25. 25 it is also a power of 5. Are you all with me? Why I did not took power of multiple of 25? It is stopping at 20. 25 contains extra 5, right? That also we need to count. So 3n equivalent to 5a plus 2. 5a plus 2. 3n equivalent to 3a plus 2 into a plus 1. 2 into a plus 1. Now if you observe closely, divisible by 3, divisible by 3. This should be divisible by 3. A plus 1 is divisible by 3. A minimum, it is 2. A minimum 2. So the lowest number, which when divided by 5, perfectly divisible, and it is also of the form 3n minus 2. 3 4s are 12 minus 2. So the number is divisible by 10 plus LCM of 3 comma 5 into k. So first it is 10, next it will be k value 15, 25, next it will be 15, 40. I hope it is clear. K value 0, 10. 10 is present in the series. K value 1. K value 1, 15 plus 10. 15 plus 10 is 25. K value 2, 30 plus 10. 10 and 25. 10 and 25. I hope it is clear. Now, here it is 5 into 2 and it is 5 into 5. There are two multiples of 5. 3n equivalent to 25b plus 2. So, this can be written as 24b plus b plus 2. So, this will be divisible by 3, divisible by 3. B minimum will be 1. If b minimum, it is 1. B minimum, it is 1. 25 ones are 25. Plus it is divisible by 3 and 25. K value 0, 25. K value 1, 75 plus 25, 100. 100, it is a exceeding 31. So in 25, there is another power of 5. So 2 plus 1, answer for this question is 3. Answer for this question, it is 3. I hope the logic, it is clear. Is the logic clear? I'm sure it should be clear to you. Power of 5 is less than power of 2. Even if you solve it orally, this will be, what will be the series? 1 into, 4 into, 7 into, 10 into, 13 into, 16 into, 19 into 22 into 25 into 28 into 31. 28 into 31. So here, if you observe here, in 25, how many multiples of 5 are there? Only one I am taking here and another one you are taking here. 25 is 5 square. Here, 5 multiples I am taking. Another 25 multiples I am taking. So separately only I am taking. Let us see whether we are getting 3. Only powers of 5 I require. I don't need any of this. 10 is 5 into 2. 25 is 5 square. 2 plus 1, answer is 3. Are you all with me? Answer, it is 3. First I will do power of 5. Then I will do power of 25. Then I will do power of 125. All these I will add it. It's a very, very important variety of questions which are very, very close to the CAT level. This kind of questions comes under the intermediate to the advanced level. I hope the idea it is clear. Let us do 2 more questions for us to understand it. If the series is in AP, find out the nth term and equate it with 5, 25, 125. Another question. 2 into 6 into 10 into 14 into and so on up to 482. If we keep on counting it, it will be a very long process. So we will go step by step. 2, 6, 10, 14 and so on up to 482. Step number 1. Once you understand the flow chart, it is very easy. Tn equivalent to a plus n minus 1 into d. A plus n minus 1 into d. So Tn is, first term it is 2. N minus 1. Difference it is 4. So this will be 4n minus 2. Tn can be given as 4n minus 2. 4n minus 2. N can start taking from 1. So n, if it can it take 121. 484 minus 2. 482. 1 less than or equivalent to n less than or equivalent to 121. So n value can move from 1 to 121. I hope the idea it is clear. Very, very good question, sir. Step number 2. 4n minus 2. It can take either a multiples of 5 or step number 3. It can take a multiples of 125. 25b. Step number 4. It can take a multiples of 125. 4n minus 2 equivalent to 125c. Step number 5. It can take 5 power 4. 5 power 4 is 625. 4n minus 2 equivalent to 625d. This is not possible. Highest value is still 482. Now slowly, step by step, counting, be very careful, sir. So these 4n equivalent to 5a plus 2. 4n equivalent to 4a plus a plus 2. A plus 2. These divisible by 4. A plus 2 should be divisible by 4. A minimum value, it should be 2. 5 2s are 10. So this will be 10 plus LCM of 4, 5 into k. 10 plus LCM of 4, 5 into k. K value 0, it is 10. K value 1, it is 30. K value 2, it is 50. Now this K value, how many it can take? It can take from 0 to, how many it can take? 20. I require 482. 24s are 480 plus 10. 480 plus 10, it is 490. So it will be from 0 to 23. 20 into 23, 460. 460 plus 10 is 470. K value 24. 20 into 24, 480 plus 10, it is 490. 0 to 23. How many multiples of 5 I got? I got 24. Are you all with me? So just take the upper limit. This will be 4n equivalent to 25b plus 2. 25b plus 2. 4n equivalent to 24b plus b plus 2. 24b plus b plus 2. 4n it is divisible by 4. It is also divisible by 4. So b minimum has to be 2. If b minimum it is 2. 50. 50 plus LCM of 4 comma 25 into k. 4 comma 25 into k. K value can be 0. It is 100. K will be till 3. 100 3s are 300. 300 plus 50, 350. 400 plus 50, 450. K value can take 4. 0 to 4, there are 5. K is 4. 100 4s are 400 plus 50, 450. K value 5. 500 plus 5, 550. It is exceeding 482. I hope the idea it is clear. Slowly we have to do. It is not a difficult question. Just finding the nth term and equating with multiples of 5. That's all. 4n equivalent to 125c plus 2. 4n equivalent to 124c plus c plus 2. 4n it is a multiple of 4. Multiple of 4. C minimum it will be 2. If C minimum if it is 2, this will be 250 plus LCM of 4 comma 125 into k. So k can take only 0, which is 250. So here 1 value, here 5 values, here 24 values. What is the number of trailing zeros for this question? Answer is 30. Very, very good question. This kind of questions you will struggle it, but it's very easy if you understand the flow chart. First step number 1 is find out the nth term. Power of 5s are less than power of 2. Equate it with a multiple of 5. Every power of highest power of 5 is also a 25 contains 5. So take the multiple powers of 5. 5a, 5 square b, 5 cube c, 5 power 4 it is 625, but the upper limit is still 482. Very, very important question. Kindly after the class is over, all the enrolled students revisit this question again. Take time to understand what is happening at each and every step. First I did all the 5 multiples. Suppose if it is there 5, 10, 15, 25 till 125. First I wrote all the multiples powers of 5. Then I wrote all the powers of 25. Then I wrote all the powers of 125. There will be extra powers of 5 that you will get in 25 and 125, that I wrote it in step number 2 and 3. Very, very important CAT model question. Please put a star mark and you can try to solve it. It's a take-home question. Try to do it on your own. 1 into 4 into 7 into 10 and so on up to 991. A practice question for you. In case if you want another practice question, 2 into 7 into 12 into 17 and so on up to 57. Find the number of trailing zeros. Find the number of trailing zeros. Find the number of trailing zeros. Try to solve this question. Take it as a take-home problem. We have done 2 examples. Do another 2 examples. This concept will be very, very clear to you. This concept will be very clear to you. I hope the idea it is clear. Idea it is clear. Which are the questions which are pending? This model, AP model also we covered. Then 2 into 5 into 8. Then factorial addition, factorial subtraction, factorial division, factorial multiplication, and without factorial. Let us solve this model. Question, please write down, sir. Find the number of trailing zeros. Find the number of trailing zeros. Same questions I am writing it here. 2 or 3 questions I will write down to the right side of the digital board. Find the number of trailing zeros. First question. 200 factorial plus 100 factorial. Number of trailing zeros is defined as the number of zeros at the end. 200 factorial can be written as 200 into 199 into 198 into and so on up to 100 factorial plus 100 factorial. 100 factorial I can take common. This will be 200 into 199 into 198 and so on up to 101 plus 1. Are you all with me? So this is a multiple of 5. 200 contains power of 5. 2 multiple of 5. 2 multiple of 5, I am adding 1. If I am adding 1 to a multiple of 5, this is not divisible by 5. It is not divisible by 5. Why? Because 200 into any number only, it is divisible by 5. Adding plus 1, that means it is of the form 5a plus 1. For factorial based problems, number of zeros at the end, it is always given by the highest power of 5. So 20 plus 4. Answer for this question is 24. Number of trailing zeros for 200 factorial plus 100 factorial, answer it is 24. Even if the same question is like this, 200 factorial minus 100 factorial. So this is nothing but 100 factorial bracket. This will be 200, 199, 198 and so on up to 101 minus 1. These is divisible by 5. 5 minus 1. These is divisible by 5 minus 1. That means this number is not divisible by 5. Number in the bracket is not divisible by 5. For factorial, it is always the highest power of 5. So first question and the second question, answer remains the same. First question and the second question, answer remains the same. Third question, 200 factorial divided by 100 factorial. 200 factorial divided by 100 factorial. Now, for factorial based problems, number of trailing zeros is based on the highest power of 5. So this it will be 200, it will be 5 40s are, 5 8s are, 5 1s are. So I will get 5 power 49 here. It is 5 power 24 into K1 by K2. 49 minus 24. How many zeros will be there at the end? For 200 factorial by 100 factorial. For 200 factorial, number of trailing zeros is given by highest power of 10. Because it is factorial, it can be condensed to highest power of 5. 5 40s are, 5 8s are, 5 1s are. 5 power 49, 5 power 24. A power m by a power n is a power m minus n. It is 25. Question number D. What if it is multiplied 200 factorial into 100 factorial? 200 factorial into 100 factorial. It is factorial. I got 5 power 49 into K1. It is factorial. 5 power 24 into K2. K1 into K2 will give you other prime bases. 5 power 73 into K3. Number of zeros at the end. Number of zeros at the end. It is given by highest power of 5 for factorial. Answer for this question will be 73. Answer for this question will be 73. Idea clear? Factorials added, factorials subtracted, factorials divided, factorials multiplied, factorials multiplied. I hope the idea it is clear. The question can also be like this. Question can also be like this. Factorials, we will raise it power. 200 factorial, power 100 factorial. F. 100 factorial, power 200 factorial. Find the number of trailing zeros. The question can also be like this. Every variety of questions, it will be there in your paid video course. You don't need to refer any other book. Everything in detail I will discuss. So 5 power 200 factorial. 200, we got 5 power 49 into K1 power 100 factorial. So these 5 a power m power n. It is a power m into n. a power m into n, a power m into n. So it is 5 power 49 into 100 factorial into k1 power 100 factorial. Anyway, k1, even if I take 2 I will get, suppose if I write it as, this will be 197 into k2. 197 into 100 factorial, it will be greater. So what will be the answer? 49 into 100 factorial. Find the number of trailing zeros for these. Power 200 factorial, power 100 factorial. 5 power 49 into k1 power 100 factorial. A power m in power n is, a bracket it is a power m into n. So here it is 5 power 24 into, I will write down it here, 2 power 97 into k3 power 200 factorial. Am I right? Power. So this will be 5 power 24 into 200 factorial into 2 power 97 into 200 factorial into some k3. So this can be written as 5 power 24 into 200 factorial, 2 power 24 into 200 factorial into 2 power 73 into 200 factorial. So if I take the combination, I will get the answer 24 into 200 factorial. Power also we did it. Factorial addition we did. Factorial subtraction we did. Factorial division we did. Factorial power factorial also we did it. Every variety of question, it should be there. I hope the idea it is clear. This answer is 49 into 100 factorial. This answer is 24 into 200 factorial. What is the next question? What if the factorials are not given? How to find the number of trailing zeros if the factorials are not given? Question is, n is 91 into 92 into and so on up to 100, let us take. We want the trailing zeros for n. We want the trailing zeros for n. Trailing zeros for n. How to get the trailing zeros? For factorial, it is the highest power of 5. So, multiply the numerator and denominator. Multiply the numerator and denominator by 1 to 90 in the numerator and denominator. 91 into 92 till 100 divided by 1 into 2 and so on up to 90. I hope the idea it is clear. So this numerator will become 100 factorial. This denominator will become 90 factorial. 2 factorials getting divided. Which process to use? Already we have seen. Which process to use? Already we have seen. 100 factorial will be 5 power 24 into k1. 90 will be 5 18s are 5 3s are 18 plus 3, 21. 5 power 21 into k2. So answer is number of trailing zeros for this question. If the factorial it is not present. If the factorial it is not present, how to do it? Divide the numerator and denominator and convert it into a factorial. Then apply the highest power of 5. A power m by a power n. It is given by a power m minus n. A power m by a power n. It is given by a power m minus n. 24 minus 21. Answer for this question is 3. I hope it is clear. Let me see if any other questions are pending. Factorial to factorial. Addition, subtraction, multiplication, division. The series is in arithmetic progression. Series is in arithmetic progression. 8 into 16. 8 into 16. 8 into 16. Now GP also we will take. Now how to find out the highest powers. So suppose if the question is like this. If the question is like this. 8 into 16 into 32 into 32 into 64 into 864 into 128. How to do it? These 8 into 1. These 8 into 2, 8 into 3, 8 into 4, and 8 into 4 it is. 8 into 8, 8 into 16. Anywhere power of 5 is there, power of 5 is not there, so answer is 0. To get the number of zeros at the end, we need the highest power of 2 and 5. Minimum 1 power of 2 and minimum 1 power of 5 should be there. So here 5 means it should have unit digit 5 or 0. Nothing is visible to me. So the answer is 0. Equality, I am sure each one of you have understood how to solve the number of trailing zeros for a variety of questions. Now we will get into solving questions present in the PDF. Till here, I am sure it should be clear to you. Till here, I hope it is clear to you. Now let us get into a problem solving. Now, questions will be very, very easy for you, sir. Let us see the first question. Find the highest power of 10 in 100 factorial. Factorial means 10 is a composite number. It is 2 into 5. It is 5 already we did. Answer is 24. First one, answer is 24. Already we did this question. Find the number of zeros at the end of 101 factorial. 101 factorial. 5 20s are 5 4s are 20 plus 4. It is 24. Second one, answer is 24. What is important for me is not this question. Now see here. Note. Note. Listen carefully, sir. Note. Very, very important note. 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 1. How many zeros are there? Number of zeros at the end. Number of trailing zeros. It is based on the highest power of 5. So 1 power it is there. Now if you see here, 6 factorial. 6 is 6 into 5 factorial. Again number of zeros at the end. 1. 7 factorial. 8 factorial. 9 factorial. All will have how many zeros at the end? 1 zeros at the end. That means starting with 1 number which is a factorial of 5 till you get the next number which is a multiple of 5. All will have 1 0 at the end. All will have 1 0 at the end. This line is extremely important to me. Listen carefully, sir. Starting with the number which is a multiple of 5. Starting with 10 factorial. Till the number which is 1 less than the multiple of 5. 14 factorial. Number of zeros at the end will remain same. Number of zeros at the end. In this case, it is 2. In this case, it is 2. Suppose if the question he is asking 101 factorial. 101 factorial. What is the multiple of 5? Just closer to 101 factorial, 100 factorial. From 100 factorial till 104 factorial, number of trailing zeros will be same. It is as equivalent to determining the number of zeros for 100 factorial. I hope it is clear. Suppose if he is asking 237 factorial has same number of zeros as 231 7 factorial has same number of trailing zeros as 235 factorial, 238 factorial, 239 factorial, and answer is all of this. Answer is all of this. What will be the answer? 237 factorial. What is the multiple of 5? Just less than 237 factorial. 235 factorial. From 235 factorial till 239 factorial, number of zeros will be same. So answer for this question is all of this. Do not waste your time in doing the number of zeros for every number. Every number. So please write down, sir. 5x factorial till 5x plus 4 factorial. The number of trailing zeros will be same. Number of trailing zeros will be same. Number of trailing zeros will be same. Very, very interesting key point. It will help us to eliminate a lot of calculation time. Otherwise, you will keep on doing it. If the number is 237 factorial, take the number which is just less than this number and a multiple of 5. Suppose 109 factorial. What are the natural number? What are the factorials where the number of trailing zeros will be same? 104 factorial, 106, 107 and 108. Are you all with me? Trailing zeros will be same. Trailing zeros will be same. Perfect idea. Idea it is, Pravar. To explain that concept only, I did the second question. First question 100 factorial. Same number of zeros will be there for 101 factorial. Third question. Third question. Find the maximum of 100 is highest power of 5. Now what we will do is 100 is 2 square into 5. 2 square into 5 square. So for 5, it is, how much it is? 5 it will be 200. And this will be 5 40s are, 5 8s are, 5 1s are, 5 1s are, 5 1s are. Find the maximum of 100 in 1000 factorial. 100 is 4 into 25. So 1000 factorial can be written as 5 power. How much it is? 248. 248. 240, 248, 249. 2 it will be. Anyway, answer is 249. 249. This cannot be. Find the maximum of 100 in 100 factorial. 100 can be written as 2 square into 500. Please change the question. This question is not clear. Find the highest power of 100. Find the highest power of 100 in 1000 factorial. 100 is 2 square into 5 square. Right? I hope it is clear. Answer is 249. Find the number of zeros at the end of the product. At the end of the product. Now if you see here, number of zeros at the end, which is trailing zeros. Here 1 it is there. Here another power of 5 it is there. Here 5 square into 3. Another 2 it is there. Another 2 it is there. I hope it is clear. Now if you see here, how many powers of 5 we got? Powers of 5. Here it is 25 into 3. It is plus 2. Here it is 5 into 3. Here it is plus 1. And here it is plus 1. So 2 plus 1 plus 1. I got 4. Now here, if I take 5 power 4 into, if I take here, this is 30. 30 is 2 into 3 into 5. Another plus 1 we got. So it is 5. Don't do these silly mistakes. These are the kind of problems where you might do silly mistakes. So 12 is 2 square into 3. 5 is 5 power 1. 15 is 5 into 3. I don't require it. 24 is 2 cube into 3. I don't require it. 13 I don't require. So 30 contains 2 and 5. 75 it is 5 square into 3. I don't require anything other than 2 and 5. 2 square, how many I got? Here 2, here it is there, here 3. 2 plus 3, 5. 5 plus 1, 6. I got 6 for 2. For 5 it is 1 plus 1, 2. 2 plus 2, 4. 4 plus 1, 5. 5 power 5 into K3. So answer is 2 into 5 power 5 into 2 into K3. Answer is 5. I hope the idea it is clear. Answer for this question is 5. I hope the idea it will be clear. In these cases, please be extremely slow and do it very slowly. There are chances sometimes highest power of 2 we will get it. I hope the idea it is clear. Next one. 1 into 3 into 5 into 7. Now, this is a very, very good question, sir. 1 into 3 into 5 into 7 and so on up to 128. 128 is 2 power 7. 128 is 2 power 7. This number is 1 into 3 into 5 into 7 and so on up to 101 into 2 power 7. 1 into 3 into 5 into 7 and so on up to 101. Listen carefully, sir. Listen carefully. This entire question solutions PDF will only be given to the enrolled students. You can see whatever I am writing, the same PDF, the enrolled students, you will get it in your course login ID. Other students, probably they can only watch the class. That's the difference between a paid and a non-paid students into 2 power 7. So this will be 5. 5, 7, 9, 11, 13, 15. This will be 15. Extra, all are odd numbers, right? 25. Next will be 35. Next will be 45. Next is 55, 65, 75, 85. And next will be 95. Only the focus will be on these numbers because I require number of zeros at the end. Number of zeros at the end. Into 2 power 7. Into 2 power 7. Now listen carefully, sir. Listen carefully. How many powers of 5 we got? Let us see. These plus 1. These plus 1. These plus 2. These plus 1. These plus 1, these plus 1, 5 into 11, 5 into 13, plus 2, and it is plus 1, and it is plus 19, 5 into 19, plus 1. Are you all with me? 1 into 3 into 5 into 7 into 9 into 11 into 13 into 15. Only odd numbers we should take. 5, 15, 25. Every time there is an increase of 10. 15, 25, 35, 45, 55, 65, 75, 85, 95. Next is 105. How many powers of 5? Maximum number of zeros. So this will be 1 plus 1, 2, 4, 5, 6, 7, 8, 10, 11, 12. So it is 5 power 12 into some other prime bases into 2 power 7. The question I change it to number of zeros at the end. 5 into 2 power 7 into 5 power 5 into K1. So 10 power 7. The number of zeros at the end, I will get 7. I will get 7. Now you don't need to do all this. You don't need to do all this. Just by looking at the question itself, I will keep the answer as 7. I will keep the answer as 7. Why I will keep the answer as 7? Now see here. 1 into 3 into 5 into 7 into 9 and so on up to 101. In this one, how many multiples of 5 I will get? 5 ones are 5 2, 5 19s are 95. Powers of 5 I am getting greater than 7. So answer will be the lowest power of 2. So answer will be 5 into 1 into 3 into 5 into 7 and so on up to 2 power 7. Here, what are the multiples of 5? 5, next 15, next 25, next 35. 5 into 1, 5 into 3, 5 into 5. 5 into 5 means extra 2 will come. 5 into 7, extra 1, extra 1, extra 1, extra 1. 75 is 25 into 3, extra 2, extra 1. So how many 5 powers I got? 1 plus 1, 2, 4, 5, 6, 7, 8, 9, 11. 12. I got 12. So 2 power 7. To get the maximum number of, there is a difference between, see here, the English statements, number of zeros. There is a difference between number of zeros at the end. Number of zeros at the end. 20300. Number of zeros at the end. It is 2. Number of zeros for this number, it is 3. Number of zeros at the end, that means at the tail end, how many zeros are there? I added at the end. Number of zeros means all the zeros wherever it is present, we have to multiply. We have to multiply. What I found out in the question? I found out in this question. I found out in this question. number of zeros at the end. I hope you understood the difference between number of zeros. Number of zeros in 20300, 3 zeros are there. Number of zeros at the end, 2 zeros are there. Understand this English and solve it orally. Next one. Next question. Another beautiful question, sir. These are all some calculation-based questions where you might do a mistake. 140 factorial into 5 into 15 into 22 into 11 into 14 into 135. It is clearly mentioned. It is a number of zeros at the end. Number of zeros at the end. It is the highest power of 10, which is the power of 2 and 5, which is the power of 2 and 5. I need the power of 2 and 5. Listen carefully, sir. 2 and 5. 11 I don't require. It is 2 into 7 I require. 135. It is 5 into 27. 27 I don't require. 7 I don't require. 22. It is 2 into 11. 11 I don't require. 15. It is 5 into 3. 3 I don't need, 5 I need. 140 factorial. Highest power of 5 will be 5 28s are, 5 5s are, 5 1s are, which will be 5 power 34 into K1. Into K1. Power of 2s will be more. So here I got 34 5s. Here I got another 5. Here I got another 5. Here I got another 5. So 34 plus 1 plus 1 plus 1. Answer for this question is 37. Not only for 140 factorial. In 140 factorial, powers of 2. Even in the first step itself, you are able to say it is greater than 70. But here it is close to 34. So 2 you don't need to take. 2 8s are, 2 4s are, 2 2s are, 2 1s are. Are you all with me? So here 34 are there, 34, 28, 5, 1, 34, here 1, 5, here 1, 5, and here 1, 5, 20, 34 plus 3. Answer will be 37. I hope the idea it is clear. Sixth one, another question. This we already did it. The best thing about our class is, in case if your fundamentals are good, you can solve a lot of problems. The number 2, 4, 6 and 8 till 100 are multiplied. 2 into 4 into 6 into 8 and so on up to 100. So this will become 2 1s are 2, 2 2s are 4, 2 3s are 6 and so on up to 250s are 100. So it is 2 power 50 into 50 factorial. Number of zeros at the end. Number of zeros at the end. For factorial, it is dependent on the power of 5. 5 10s are 5, 5 2s are 10. 10 plus 2. Answer will be 12. Answer will be 12. Only for factorial problems. Only for factorial problems. Number of zeros at the end is dependent on the power of 5. So 5 10s are, 5 2s are. 10 plus 2, answer is 12. Easy questions. Already questions, whatever we solved it. I am solving it little fast. Next one. Read this question. The number of zeros at the end for 1 power 20 into 2 power 20 into 3 power 20 and so on up to 2 power 20 into 3 power 20 and so on up to 38 power 20. So this will be equivalent to 1 into 2 into 3 and so on up to 38 power 20. Product of all natural numbers from 1 to 38. It is called 38 factorial. So 38 factorial power 20. Number of zeros at the end. For factorials only, it is dependent on the powers of 5. 7 plus 1, 8. So 5 power 8 into k power 20. A power m into n. It is m into n. 8 20s are 160. 8 20s are 160. 1 power 20, 2 power 20, 3 power 20, and so on up to 38 power 20. Powers it is the same. What if it is different? That also we will solve. 1 into 2 into 3 till 38. 38 factorial power 20. Number of zeros at the end. For factorial is the power of 5. 5 sevens are, 5 ones are. 7 plus 1, 8. 5 power 8 into k power 20. A power m power n, it is equivalent to a power m into n. A power m into n. 8 into 20. Answer is 160. 8 into 20, it is 160. Now, each and every question is a variety of questions, sir. Ensure that you first read the question, understand the question, and try to solve it. Next question. Find the number of zeros in the end. 1 power 3. This 1 is becoming 2. 3 is becoming 4. Increase in 1 in base. Increase in 1 in power. So, increase in 1 in base. Increase in 1 in base. So, it is 5 power 7 and so on up to 26 power 28. Before number 1 less than 25 power 27. 1 less than 24 power 26. 26. Now, if you see here, seems like a complex question. With understanding the question, you can solve it. Every second term is a multiple of 2. Every second term is a multiple of 2. Every fifth term is a multiple of 5. So, in totally 26 terms, there are only 5 terms which are multiples of 5, but there are 14 terms which are multiples of 2. So, we can take only powers of 5. 5 power 7. Next will be 10 power. It is 2 more than, right? 10 power 12. Next will be 15. 2 more than 17. Next will be 20. 2 more than. Next will be 25. 2 more than 27. Only this is enough for me. I hope it is clear. So it is 5 power 7. 10 can be written as 5 into 2 power 12. 15 can be written as 5 into 3 power 17. 20 can be written as 5 into 4 power 22. 25 can be written as 5 square power 27. Now, just adding the powers, you will get the answer. First is 7. Next it is 12. Next it is 17. Next it is 22. Next it will be 2 into 27. 2 into 27. I hope it is clear. So all the unit digits in the answer options are different. I will just attack the unit digit. 7 plus 2, 9. 9 plus 7, 16, 6. 6 plus 2, 8. 8 plus 4, 12. Answer is 112. Answer is 112. Unit digit in the answer options are different. If you solve it, 54 plus 22 plus 36. 76, 112. You don't need to find the entire number. Just attack the unit digit. I hope it is clear why I took only the powers of 5. Total 26 terms are there. Every fifth term is a multiple of 5. So there are totally only 5 terms are there, but there are 14 terms are there which are multiples of 2. So powers of 2 will be greater than powers of 5, or powers of 5 will be less than powers of 2. Powers of 5 will be less than powers of 2. I hope the idea it is clear. So answer for this question will be 112. Very, very good question. Please put a star mark, sir. Trailing zeros. What teachers will teach you for 15 minutes, we will do most comprehensively. Another question. Find the maximum number of zeros at the end. That's a very, very important wording. Find the maximum number of zeros at the end. Same like this we will solve. 1 power 100. Next it is 2 power 99. Next it will be 3 power 98. 4 power 97. 5 power 96. And so on up to 100 power 1. 100 power 1. Base and power sum is 101. Base and power sum is 101. Every second term, it is a multiple of 2. Every fifth term, it is a multiple of 5. So there are 20 terms which are a multiples of 5. So power of 5 is less than power of 2. Power of 5, it is less than power of 2. So only attack the power of 5 power 96. Next it is 10. This sum is 101. 1 plus 100, 101. 2 plus 99, 101. 98 plus 3, 101. So 10, this will be 10 plus 91. Next it will be 15. Here there is 5 increase. Here there is 5 decrease. Here there is 5 increase. Here there is 5 decrease. Here there is 5 increase. 5 increase. So here there is 5 decrease. I hope it is clear. And so on up to 100 power 1. 100 power 1. Now if you observe carefully, what we will do is, first we will do powers of 5. Then we will do powers of 25. Then we will add it. In that way, the logic will be very, very easy. Every term contains 5. So 96 will come, 91 will come, 86 will come, and so on up to 1 will come. Are you all with me? In addition to this, 25 power 76 will come. Next one, 25 multiple, 75 power 26 will come, 100 power 1 will come. 100 power 1 will come. 25 is 5 square. 1 5 we have taken. So another 76 will come here. Another 5 square. Another 26 will come here. 25 into 4. Another 1 will come here. I hope it is clear. Power of 5, power of 25 and 1. Power of 5, power of 25 and 1. 5 power 96. Why we are adding 5 power 96? 10 is 5 into 2 power 91. So 5 power 96 into 5 power 91. 96 plus 91 plus 86. Every number is a multiple of 5. So it will come. But there are certain terms where it will double will come. 25 it is. 25 I can take it as 5 square power 76. So 5 power 76 into 5. This we wrote. So this I am writing. 75 is 5 square into 3. This we wrote. Another 26 we are writing. Are you all with me? 5 square into 4. 1 5 we wrote. So another 5 we are writing. Just to do the AP series sum. So this will be 76 plus 27. This will be 103. This will be 103. So 96, 91. Use AP series, add the values, you will get the answer. Just calculation intensive, but very, very good question, which gives you an understanding that only concentrate on powers of 5. Only concentrate on powers of 5. Another question, sir. This is an exam model question. See here. Find the number of zeros at the end. 10 power 1. It will have 1 0 at the end. 10 power 1 plus 10 square. 100 plus 10. 110. It will have 1 0 at the end. 10 power 1 plus 10 square plus 10 cube. 1000 plus 100 plus 10. 110. Again it is 1110. Only 1 0 at the end. Only 1 0 at the end. To 10 power n, you are adding 10 square. So this number is greater than this number. Obviously, 10 power any number will have 1 0 at the end. This number is greater than these two numbers. So 1 0. This number is greater than these numbers. 1 0. Last number is greater than every other number. So 1 0 will be there at the end. Very, very easy question. Different varieties of questions, sir. Next one. This model also we already solved. 1 factorial. 1 factorial. 1 power 1 factorial. 2 power 2 factorial. 3 power 3 factorial. 4 power 4 factorial. and so on up to 10 power 10 factorial, 1 power 1 factorial, 2 power 2 factorial, and so on up to 10 power 10 factorial. Listen carefully, sir. Every second term I am getting a multiple of 2. But every fifth term it is a multiple of 5. So power of 5. Power of 5 is less than power of 2. Power of 5 will be less than power of 2. If power of 5 is less than power of 2, this will be 5 power 5 factorial into 10 power 10 factorial. So this will be 5 power 5 factorial. 10 it is 5 into 2 power 10 factorial. So answer will be 5 factorial plus 10 factorial. Already we did these kind of questions where we are taking only power of 5 less than power of 2. Right after this class, trailing zeros, watch the class in the next 48 hours to all the enrolled students. Watch it, complete it, and move on to the next topic. By this next weekend, your entire number system revision should get over. Find the number of zeros at the end. Find the number of zeros at the end. Next one, find these already we did this kind of questions, factorial additions. Find the number of trailing zeros. Please add that keyword, sir. Otherwise, mathematically it will be incorrect. So, n is 30 factorial plus 20 factorial plus 10 factorial plus 10 factorial. So, this can be written as 30 factorial plus 10 factorial. 30 into 29 into 28 into and so on up to 20 into 19 and so on up to 10 and so on up to 1 plus 20 into 19 into 18 and so on up to 1, 10 and so on up to 1 plus 10 factorial. Here it is 10 factorial, here it is 10 factorial. So 10 factorial if I take common, 30, 29 and so on, plus 20 into 19 into 18 and so on, plus 1, plus 1. Already we did this model in our class. This is a multiple of 5. This is a multiple of 5, plus 1. The number is not divisible by 5. Number, it is not divisible by 5. Number inside, it is not divisible by 5. 10 factorial. What factorial? It will be the highest power of 5. So answer will be 2. Very, very easy question. We did the similar question for 200 factorial plus 100 factorial. That is the beauty about the class. If you start listening to the class from the fundamentals, it will be very easy. Another fundamentals question, sir. Find the number of zeros at the end. Zeros at the end is highest power of. It is the highest power of 2 and 5. Highest power of 2 and 5. So we should get highest power of 2 and 5. Now these, let me take common. So it is 8 power 121. This will be 8 square minus 8 minus 1. This will be 3 power 221 common. This will be 3 square minus 3 minus 1. So 8 power 121. 64 minus 9. 64 minus 9. It is 57. 3 power 221. 3 power 221. 9 minus 3, 6, 6 minus 1, 5. 6 minus 1, 5. 6 minus 1, 5. Now see here. Listen carefully. Here 1, 5 it is there. I can take 1, 2 from here. Answer is 1. Answer is 1. Take 8 power 121 common. 8 square minus 8 minus 1. 64 minus 8, 56. Sorry, 64 minus 8. It is 56. It is 55. Sorry, I made a mistake. These calculation mistakes, please try to avoid it. Calculation mistakes, don't try to do it, sir. I just made a calculation mistake. These 8 power 121. 64 minus 8, 56. 56 minus 1, 55. It is 3 power 221. 9 minus 3, 6. 6 minus 1, 5. Here 1, 5 it is there. Here 1, 5 it is there. Answer is 2. Answer for this question is 2. Is the idea clear? Very, very easy question. Next one. How many zeros will be there at the end of the expression? For a factorial, number of zeros is dependent on the power of 5. So it is 5 8s are 40, 5 1s are 5. It is 5 power 9 into K1 divided by, this will be 5 2s are 10. 5 square into K2. 9 minus 2. Answer for this question will be 7. Answer for this question will be 7. Idea it is clear, right? For factorial problems, number of zeros at the end is the highest power of 5. For simple problems, let us not waste too much of time. Another exam model question. Find the number of zeros at the end. When we multiply first 50 prime numbers, when you multiply first 50 prime numbers 2 into 3 into 5 and so on, 2 into 3 into 5 and so on, whether it is first 50 prime numbers or 100 prime numbers or 1000 prime numbers, 2 into 5, 10. There will be only 1 0 at the end. The prime number which is even is 2. So single power of 2 it is there, multiplied by single power of 5. Single power of 5. Here the single power of 5. Rest all the numbers are divisible by, there are no numbers which are divisible by 5 and a prime number, right? I hope it is clear. There are no even numbers other than 2 which are prime numbers, 2 into 5. So only 1 0 will be there. Next one, another question, sir. This kind of questions you have to be very, very careful and solve it very slowly. Next it is 2 square into, let me write down, 5 power 4 into 4 square into 10 power 8 into 6 power 10 into 5 power 12 into 8 power 14 into 20 power 16 into 10 power 8 into 25 power 20. What is the number of trailing zeros? First we will do it with 5. Here 5 power 4. So here 5 power 4 we got 5 power 4. Here 10 power 8. That means another 5 power 8 we can get. Here it is 5 power 12. Here it is 20 power 16. It is 5 power 16. 10 is 5 into 2 power 8. 5 power 8. Here it is 25. 5 square power 20. That means totally how many number, highest power of 5? 4 plus 8, 12. 12 plus 12, 24. 24 plus 16, 40. 40 plus 8, 48. 48 plus 40. 48 plus 40, 88. Let me check it out whether I missed out anything. Now see here, sir. Here I got 5 square, so it is 40. Here it is 8. Here it is 16. Here it is 12. Here it is 8. Here it is 4. So 4 plus 8, 12, 24, 40, 48, 88. 88 it is not there. So let me check it out with 2. 2 square into 4 square. 4 square is 16, which is 2 power 4. 6 is 2 power 10. 8 is 2 power 3 power 14. 3 14s are 42. Next it is 20. 20 it is 2 square. It is 2 power 32. 10 it is 2 into 5. 5 8s are 40. 25. So it is over. Here it is 2 into 5 power 8. So here it is 2 power 8. 2 square into 5. 2 square it is 32. I hope it is clear. Any cases that we are missing, let us do one by one. So power of 2s. Power of 2s will be 32 plus 8, 40, 82, 92, 96, 98. That means in power of 5, we must have done some calculation mistake. 5 power 4. So 1 4 definitely yes. 10 power 8, 5 into 2 power 8. So it is 8. This is also right. 5 power 12. It is also 12. Right. 20. 5 into 4 power 16. 5 power 16. It is also right. 5 into 2 power 8. It is also 8. It is right. 25 is 5 square. 5 square means it is 40. So this will be 48, 64, 76, 84, 88. I got 88 for power of 5. That means for power of 2, let us do. 2 square into 4 square is 2 power 4. 10 is 2 power 8. 6 is 2 into 3 power 10. 2 power 10. 8 is 2 power 3 power 14. 20 it is 2 square, it is into 16. 10 it is 2 into 5. 2 into 5 power 8. Why am I doing all this? Okay, I got another idea. It is 5 square. So this will be 632 plus 8, 40. 40 plus 42, 82, 92, 100. 104, 106. Calculation, it is not matching. You can also go with the another method. That is, it is 10 power 8. Last time we will do. 20, it is 10 into 2. It is 10 power 16. 2 power 16, I'll write down here. Again, it can be combined with 5 power 12. So, 10 power 12 will come. Next one, 10 power 8 will come. Next one, 4 square, 16, 5 power 4, 10 power 4 will come. So how much answer? 24, 36, 36 plus 8, 44, 48. That means remaining 2 power of 8. Calculation, it is not matching. Please check it out if there is any calculation mistake. If my answer is right, write down the right answer. Calculation problem, now it is. 18th question. Now 18th onwards, these are all very, very good questions, sir. 18th, 19th, now see here, sir. 19th first we will solve. 18th is a very good question. 10 power 4, 10 power 4 power 50. It is 10 power 200. 10 square power 30, 10 power 60. It is 10 power 260. Number of trailing zeros. It is dependent on the highest power of 10. So answer will be 260. Answer will be 260. Very, very easy question. If you, I will solve this question, sir. Very, very easy question. Now see here. I will write down the question like this. From 1 factorial till 5 factorial. Till 5 factorial. First I will write like this. Number of zeros. Next is total number of trailing zeros. Total number of trailing zeros. From 1 factorial till 4 factorial. Is there any 5? No. So 0. Listen carefully, sir. Next, already we discussed. From 5 factorial till 9 factorial. We discussed the number of zeros will be same. So each one will have 1 0 at the end. Like that from 5 factorial till 9 factorial. 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. Total number will be 5 into 1. There will be 5 zeros. Why it is 5 zeros? 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9 factorial. Here there is 1 power, here there is 1 power, 1 power, 1 power, 1 power. So it is 5 power 5, 5 zeros. Listen carefully. From 10 factorial till 14 factorial. 5 into 2, 2, 5, 5 again, 1 zeros are there. 1 into 5. Again it is 5. 15 factorial till 19 factorial. Again, 5 power of 5. All are multiples of 5, only ones. Again 1 into 5. It is 5. It is 20 factorial till 24 factorial. 20 factorial, 20 factorial, 20 factorial. Now, if you see here, sir, I made here 10 factorial. There are 2 zeros are there at the end. 2 into 5. I hope 2 zeros, why it is? 5 2s are 10. Here also, 5 3s are 15, right? 15 factorial to 19 factorial. It is 3 into 5. 5 4s are 20. 4, like that 5 numbers are there. 4 into 5. It is, let me write down it as again. I hope the idea it is clear, right? From 5 factorial, there is 1 factorial till 9. From 10 factorial, what is the number of trailing zeros from 10 factorial? 2. Like that, 2 I will get for 10 to 14. Total 5 are there. So 2 into 5, it is 10. Here it is 3 into 5, it is 15. Here it is 4 into 5, it is 20. Are you all with me? Now, if you see here, from 25 factorial till 29 factorial, 25 factorial, how many zeros are there at the end? 5 plus 1, it is 6. Like that, 5 numbers are there. 6 5s are 30. From 30 factorial till 34 factorial, 30, how many zeros are there? 5 6 are, 5 1s are. 6 plus 1, 7. 7 5s are 35. Are you all with me? Next one, 35 factorial till 39 factorial. 35 it is. 5 7s are, 5 1s are. 8 into 5. 8 into 5. 40. I will tell you an optimal method. 40 factorial till 44 factorial. 9 into 5. 45 factorial. It is 10 5s are there. 5 9s are, 5 1s are. So answer is 1 into 5, 2 into 5, 3 into 5, 4 into 5, then 6 into 5, 7 into 5, 8 into 5, and then 9 into 5. So answer is 5 plus 10 plus 15 plus 20 plus 30 plus 35 plus 40 plus 45 plus 10. This is the total answer. I hope it is clear. Very, very good question. I will spend another 10 minutes on these various models of this question. From 1 factorial to 4 factorial, there are no 5s. So 0. Total number, it is 4. 4 into 0, 0. 5 factorial contains 1 power of 5. From 5 factorial till the next multiple of 5, the number of zeros at the end will be 1. 5 factorial, 6 factorial, 7 factorial, 8 factorial, 9. So 5. 5 into 1, 5. 10 factorial, there are 2 zeros. From 10 factorial till 4 factorial, 2 into 5, 10. So we have to go till 5, 10, 15, 20. 25, there is a jump. So 20 factorial contains 4 zeros at the end, but 25 factorial contains 6 zeros at the end. From 4 zeros to 6 zeros, there is a jump. I hope the idea it is clear. So answer is directly add these values. You can further optimize this one. Sample questions, sir. Sample questions so that you can do orally, sir. Suppose if the question is 25 factorial till 50 factorial, till 50 factorial, he is asking trailing zeros. How many zeros are there at the end for this product? What is the product? 25 factorial into 26 factorial and so on till 50 factorial. Listen carefully, sir. First we will do this. 25 factorial till 29 factorial. Number of trailing zeros will be same. For 25, how many it is? 5 5s are, 5 1s are. 5 plus 1, it is 6. 6 into 5, it is 30. Then what is the next multiple of 25? 5 power 1 is 5. 5 square is 25. Then it is 5 cube is 125. Then it will be in serial order. 30 factorial till 34 factorial. Next number I will get 7 into 5. You can cross check. 5 6 are, 5 1s are. 6 plus 1, 7. Next for 35 factorial till 39 factorial. Next number I will get 8 into 5. I hope you understood the idea. From 40 factorial till 44. Next number I will get, because there are no another multiples of 25 that are coming. 45 factorial till 49 factorial. 10 into 5. 50 factorial. 50, how many zeros are there? 5 tens are, 5 twos are. It is 12. So 6 into 5, 7 into 5. It is coming sequentially. Unless and until next power of 5 comes, it will come sequentially. It will come sequentially. These 30, these 35, these 40, these 45, these 50, and it is 12. I hope the idea it is clear. 65, 105, 150, 200. So the number of trailing zeros for the product of these factorials, it is 212 factorial. 212 factorial. Very, very good question. Whenever you encounter the powers of 5 square, 5 cube, be very, very careful. 25, it is 6 zeros. From 25 factorial till 29 factorial, 6 zeros will be there. So 6 into 5, 30 zeros I will get. Here 6 zeros, 6 zeros, 6 zeros. 6 into 5, 30. 7 into 5, 30. One more question we will solve so that you will understand the nature. Very, very good problems we are going to solve, sir. Suppose if the question is, let me solve 120 factorial till 145 factorial product. 120 factorial into 121 factorial and so on till 145 factorial trailing zeros. 120 factorial into 121 factorial and so on up to 145 factorial trailing zeros. So from the starting number, which is a multiple of 5, till the 124 factorial, number of zeros will be same. 125 to 129 factorial, 130 factorial to 134 factorial, 134 factorial to 139 factorial, 140 factorial to 144 factorial. Here it is 144 5 factorial. Total number of trailing zeros. Total number of trailing zeros. Listen carefully, sir. Total number of trailing zeros. 120 to 124. First we will do for 120. It is same. 5 24s are 120. 5 4s are 20. 24 plus 4, 28. 28, I got it for 5 numbers. But 125, it is a power of 5. 125 is 5 cube. So the number, it will not be in sequential order. 5 25s are, 5 5s are, 5 1s are, 25. Here I got 5 24s are, 5 4s are, 5 25s are, 5 5s are, 5 1s are. 31 I got. So it is 31 into 5. Why there is extra 3? Because 125 is 5 cube. Again, 130. It will be next number only. 32 into 5. Why it is 32? 5 26 are, 5 5s are, 5 1s are. You can directly write. These 33 into 5. Here it is 34 into 5. Why 5? From 140 factorial till 144 factorial. 145. This will be 5 29s are, 5 5s are, 5 1s are. Here it is 35. Add all the values, you will get the answer. Add all the values, you will get the answer. I hope the idea it is clear. How to find out the number of trailing zeros if the factorials are multiplied? Keep an eye on. Keep an eye on 5 power x factorials. Keep an eye on 5 power x factorials, whether it could be 25 factorial or 125 factorial or 625 factorial, and so on. Keep an eye on all these numbers. There will be a jump. There will be a jump. Even for 25 factorial, there is a jump of +2. Why? Because 25 is 5 square. 25 is 5 square. 125 it is 5 power 4. 125 it is 5 power 4. One more example, I will do it. 620 factorial into 621 factorial and so on up to 630 factorial. 630 factorial, number of trailing zeros at the end. Number of trailing zeros at the end. 620 factorial into 621 factorial and so on up to 630 factorial. I am trying to tell you the concept of 5 power k factorial. So 620 factorial till 624 factorial. One number will be there. Let me see what will happen for 625 factorial till 629 factorial, and it is 630 factorial. These we are determining the number of trailing zeros. We are determining the number of trailing zeros. Only for the multiple of 5, take it and do into 5. That's all. Number of trailing zeros. Number of trailing zeros. Listen carefully, sir. 620. How many I will get? 5 12s are 60, 5 4s are 5. 2s are 10, 5 4s are 5 4s are 20. So how many I got? 24 plus 4, 28. 124 plus 28. 152 zeros. The same number will be there from 620 to 624 factorial. Let me see what is happening for 625 factorial. 625 is 5 125s are, 5 25s are, 5 5s are, 5 1s are. So this will be 125 plus 31, 156. Now you understood it. 625 is 5 power 4. 5 power 4. So extra 4 increase it will be there. 156 into 5. So this will be 157. I hope you understood. From 25 factorial, there is an increase of 2. From 125 factorial, there is an increase of 3. From 625 factorial, there is an increase of 4. Only determine this. All these numbers will have same number of zeros at the end. Same number of zeros at the end. 625, there is a jump of 4. Idea clear? Next one. This is a very easy question. Next one. Find the number of zeros at the end. Already we did this model. Powers are same. So this will become 1 into 2 into 3 till 32 power 5. So this will be 32 factorial power 5. So 32 factorial, it will be 5 6 are, 5 1s are. So 5 power 7 into k power 5. A power m power n. 7 5s are 35. Answer for this question is 35. Answer for this question is 35. Answer for this question is 35. I hope the idea it is clear. Similar question we did it. 1 cube into 2 power 4 into 3 power 5 into 4 power 6 and so on up to 25 power 27 into 26 power 28. Every second term is a multiple of 2. Every fifth term is a multiple of 5. So power of 5. Power of 5 is less than power of 2. Power of 5 is less than power of 2. Power of 5 is less than power of 2. So only attack the powers of 5. 5 power 7. There is an increase of 2. Again there is an increase of 2 to the power. 15 power 17. Next it will be 20 power 22. Next it will be 25 power 27. Only get the answer from these numbers. Every fifth term is a power of 5. Every second term is a power of 2. So power of 5 will be less than power of 2. So how much it will be? Here I will get 2 into 27. 2 into 27. Here it will be 5 into 4 power 22. Oh, these powers are raising, right? 5 into 3 power 17. 5 into 2 power 12. And 5 power 7. So the number of 5s will be 7 plus 12 plus 17 plus 22 plus 2 into 27. This is the number of 5s at the end. 54 plus 22, 39, 51, 58. 58. 54 plus 58. Now what is he asking? He is asking why all the answer options are 20, 22. No, this will be 24 power 26. 24 power 26 only. 2 cube into 3 power 26. I got 78. So definitely answer options all are incorrect. Answer options. I hope the approach is clear. Approach is clear. Once you do the approach, any calculation mistake is there, correct it. If this kind of 20 means, see here, 25 power 27 only I am getting 5 power 54. Where is the question of 20, 22, 24, 26? It cannot be. Answer, this will be the answer. All the trailing zeros questions. All the trailing zeros questions. Now see here. Find the number of zeros at the end of 378 factorial. I will do it with 375. It will be easy. 5 17s are, 5 15s are, 5 3s are. Answer is 93. Why? Because 375 factorial till 379 factorial, number of zeros, trailing zeros will be the same. Number of trailing zeros, it will be the same. Number of trailing zeros, it will be the same. This is an easy question. Let us not waste too much time. Find the number of zeros for 1000 factorial. 5 200s are, 5 40s are, 5 8s are, 5 1s are. Answer is 249. Answer is 249. I hope it is clear. Next one. Already we did this kind of questions. I think these options are only kept here, sir. 20, 22, 24, 25. Same options. The other question answer options are kept here, sir. I hope you understood the mistake. Next one. Find the number of zeros. Again, the same answer options are kept. Right? It's a typist mistake. No trailing zeros. These are all odd numbers. Odd numbers will not, product will never give a power of 2. Answer is no trailing zeros. This question already we did it. Similar question. Now these, see here, sir. 3 power 3, 4 power 4, 5 power 5, 49 power 49. So these 3 power 3, 4 power 4, 6, 5 power 5, and 6 power 6, 7 power 7, 10 power 10, and so on up to 49 power 49. Every second term is a power of 2. Every fifth term starting from 5 power 5, it is a power of 5. So power of 5 is less than power of 2. Power of 5 is less than power of 2. So this will be 5 power 5, 10 power 10, 15 power 15, 20 power 20, 25 power 25, 30 power 30, 35 power 35, 40 power 40, 45 power 45. 45 power 45. Only thing whether it is 5 square factorial, at that time be careful, sir. So how many it will be? 5 plus 10 plus 15 plus 20. 25 is 5 square. 2 into 25. Plus 30 plus 35 plus 40. It is plus 45. whatever the answer that you get it, that itself will be the answer. That itself will be the answer. 27th question. 27th. These already we did this question. It is 1 factorial. So power of 5 only I am taking. 5 power 5 factorial into 10 power 10 factorial. Answer is 5 factorial plus 10 factorial. Typist, I'll speak to typist. They have done lot of repeated questions and some calculation mistakes. Now 3200 plus 40000. So this will be, how many zeros will be there? These 47,000. Now, or probably what you can do is, can you take 10 square common? This will be 32 plus 10 square. This will be 400. This will be 320. This will be 150. This will be 150. All are multiples of 10 with unit digit 2. So answer is highest power of 2 will be more than the highest power of 5. Here again 20 into 40 into 7,600 into 600. Here there are 3 zeros at the end, 2 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 zeros at the end. 6, 8. 8 plus 3, 11. Very, very easy question. But some of them are asked in examination. 100 factorial into 200 factorial. Already we did this question. 100 factorial into 200 factorial. These 5 power 24. It will be these 200. 5 40s are, 5 8s are, 5 1s are. 5 power 49 into K1. Answer is 73. Answer is 73. Now, see here, sir. These are all some of the questions which came in previous year management entrance exam. So, I listed out all the possible question. 2 power 2222 into 5 power 555. This can be written as 2 power 222 into 5 power 222 into 5 power 333. 10 power 222. The number of zeros at the end, it will be 222. It will be 222. Now, these already one. This question already we discussed. The largest number is highest than the smallest number. So, this will be how many zeros? 9 plus 7, 16, 21, 24, 25. These 2 power 25. 6, 10, 18, 28. 5 power 28. So the least will be 25. 2 into 5 power 25 into 5 power 3 into K. Answer will be 25. Till here clear, right? So this will be same model we did it. 3 power 121 if I take 3 square minus 3 minus 1. It is 2 power 121, sir. 2 power 119 if I take. 119 if I take. 2 square minus 2 minus 1. So 3 power 121. 9 minus 3, 6. 6 minus 1, 5. 2 power 119. 4 minus 2, 2. 2 minus 1, 1. So 1 is the power. 1 is the power. I hope till here it is clear, right? Now this question already solved it. This 38th. We will start with the 38th question.